thickness of the substrate stable at 1 millimeter, as you see here, and we used a lenticular lens with focal point which was about 36 centimeters. What we found out is that until the distance 36 centimeters, the same as the focal point, the visibility started increasing, which means that we had more invisibility effect. But after the focal point, the visibility started increasing in the same rate that it would decrease. So we have less invisibility effect. So I should also mention that in the focal point, invisibility was also 0%. So we had the greatest invisibility effect. I suppose I didn't mix invisibility and visibility. Um, so the first hypothesis was found to be incorrect, as whenever we increase the thickness, we have less visibility, so the invisibility effect was not lowered. And the second hypothesis was partially correct because, as I have already mentioned, the invisibility effect does lower, but that's only after the 36 centimeters, which was the focal point, but it would get greater until the focal point. So whenever we move away from the focal point, the invisibility starts fading away slowly. So the conclusions we made was that changing the thickness of the lenticular lens of the substrate of the lenticular lenses can affect the invisibility effect in two ways. One is through the Beer's law, that means changing the area in which light has to travel, and the other one is through changing the angle between the extreme ray and the normal ray, which is basically the parameter R. And also we found out that when we move away from the focal point, the invisibility effect fades away. Those are our references, and thank you for your attention.
Thank you very much. Now let's proceed with questions of the opponent to the reporter. Opponent?
Yes. Just a second. These are the questions, right? Like I can put the presentation a little bit later. Can you hear me?
Sorry,
Yes.
say again.
Yes.
Yeah. Okay. I'm wondering if these are like just the questions. Like, may I put the presentation a little bit later?
Okay, you're going to ask later in the discussion part?
No, no, no. I'm like going to put my points right now, but like the presentation would be later, like on the discussion.
Yes, so first we have to do some clarifying questions. If you don't want, you can prepare your opposition and state your opposition later. What would you
Okay.
like?
Fine.
Okay. Okay, we're waiting for you to create your opposition and tell us whenever you're ready. Okay?
Sure. Okay.
Should I answer my screen?
Yes. Okay, Vanya, are you ready? You need more time?
Yeah, we are ready.
Okay, please share your screen.
Okay, well, first of all, we would like to introduce ourselves a little bit again. We're Team Mexico. My name is Vania Garcia. I'm gonna host this program, and well, it's our leader Diana Garcia, Daniela Mora, Maria Fernanda, Stefania, and Kenny. Okay. First of all, we would like to congratulate the team because you showed excellent understanding of the formulas used on this experiment, and you had a good theoretical model and frame. However, we think that you focused on the wrong part of the experiment. The experiment point was to prove how would variations on the shape of the lens and on its structure would vary the visibility of said phenomenon. And we think that failed because you explained how the phenomenon works, not how it variate. You showed a great experimentation on the width of the lens, but we think that there are certain things that you could have experimented as well. For example, if you had played a little bit with the shape of the lens, like besides the ripples that it's supposed to have so the phenomenon works, what would happen if the lens was concave or if it was convex instead of completely like plane? We would also like to think like we already well you explained that for the phenomenon to work you need the lens to have some ripples,